The ground beneath your feet feels solid and still, but in reality, it is constantly moving. Continents slowly drift apart, collide, sink, and rise. This ongoing process is called plate tectonics, and it shapes the surface of our planet. To understand how Earth's crust moves, we first need to understand Earth's structure. Our planet has three main layers: the core at the center, the mantle above it, and the crust on the outside. The crust is the thin, outermost layer where we live. Compared to the rest of Earth, it is extremely thin and relatively rigid, but it is not one continuous shell. Instead, the crust is broken into large and small pieces called tectonic plates. Some plates carry continents, others form the ocean floor. These plates rest on top of the upper mantle, which behaves like a very slow-moving, semi-solid material. You can think of the plates as floating on a gradually flowing layer beneath them. What drives their movement? Deep inside Earth, heat from the core creates convection currents in the mantle. Hot material rises, cool material sinks, and this slow circulation transfers energy upward. These convection currents gently push and pull the tectonic plates. The movement is slow, typically only a few centimeters per year, about as fast as your fingernails grow. But over millions of years, that slow motion reshapes the planet. Where plates meet, dramatic geological activity occurs. There are three main types of plate boundaries. At divergent boundaries, plates move apart. As they separate, magma rises from below and forms new ocean crust. At convergent boundaries, plates collide. In some cases, one plate is forced beneath another in a process called subduction, leading to earthquakes and volcanic activity. When two continental plates collide, neither easily sinks, and the crust crumples upward, forming mountain ranges. The Himalayas were created this way. At transform boundaries, plates slide past each other horizontally. The friction that builds up along these boundaries can be suddenly released as powerful earthquakes. Earth's continents have not always looked the way they do today. Hundreds of millions of years ago, most of the land was joined together in a single supercontinent called Pangaea. Over time, plate movements slowly separated it into the continents we recognize now, and that movement has not stopped. The continents are still shifting, just very slowly. Plate tectonics is not just about earthquakes and mountains. It plays a crucial role in regulating Earth's carbon cycle, forming new land and mineral resources, and influencing long-term climate stability. Without the constant recycling and reshaping of the crust, Earth would be geologically inactive, more like a dead planet. The surface of our planet may seem stable, but we live on a world that is always in motion. The movement is slow, the impact is enormous.